This is Jesse, AI7RK, coming to you from my outdoor workbench today. It's a beautiful sunny afternoon here. Very unusual for February. So if you watched my POTA activation out at the Olmsted Place State Park, the Homestead POTA, you'll see that I was a little bit rough on my linked dipole. Pop this little guy right here. So today I'm going to go ahead and repair my linked dipole. I could do this one of a couple ways. I could try to splice this wire, solder it, put some heat shrink over it, try to repair it like that, but I'm not going to. You got to keep in mind this bears the entire weight of all of the rest of the dipole. Everything is hanging off of this. That's why I broke to begin with. I was being a little bit rough and kind of yanking out a little bit and it popped loose. So what I'm going to actually do is all of my hot glue weatherproofing that I put on here, I'm actually going to slowly melt and cut some of this back, re-expose the center conductor of my coax inside there, and then just recut a new 6 meter length here for the one side of my dipole. So this is the six meter, of course, the very first element. And this is where this gets a little bit tricky. So how the linked dipole works is you have your 6 meter element, and then you have these cute little clippies here. And then on the other side of this is the 10 meter element. And then on the other side of that is the 12 meter element. The other side of that, the 15, the other side of that, 17, 20, 30, 40, blah, 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 right? All of these are reliant on the length of my 6 meter dipole, the initial original first link 6 meter dipole. So if I'm off on my 6 meter length, it's going to alter the frequency on every other link after that. So this is my plan here, is I'm going to cut all of this loose. I'm going to melt off the hot glue that's around here, weather sealing it. I'm going to desolder that center pin of the coax, desolder that, pull all this off, and then I'm going to go and measure using my my new section of wire from here, and I'm just going to trace this wire on my other still connected element of the dipole, getting it as close to matching as I possibly can. And then I'm going to put it all back together. I'm going to cut out the broken 6 meter link here, and then reattach the new one. I'm going to check and tune, isolate out just the 6 meter element, check and tune it for the right frequency. And then I've got to check every other link after that to make sure that they're where I want them to be in the band. I'm both kind of fortunate here and kind of cursed here by the fact that my other one is still connected, because it is wound through the center here, the support for the toroid, for the one-to-one. It's wound through here, so matching that length is going to be a little bit tricky. And you want to get as close as you possibly can on a dipole for your two elements to be the same. So I'm going to be kind of hoping and dreaming with this one and hoping it works. So let's get started. So all I'm doing here is slowly melting back some of the hot glue, peeling it off, and getting it out of the way. I'll be able to clean this up a little bit when I'm done, but right now I'm just trying to get the material out of the way. I'm just peeling back as much of this hot glue as I can. So all I'm doing is exposing the solder joint here on the exposing the solder here on the center of that coax. I'll start pulling this through here. All right, so there we go. I'm gonna peel off some of this here so I can get a nice clean solder in here. I don't want to heat it up too much because I don't want the dielectric on the center conductor of the coax to go. Peel off some of this hot glue. Get my holes back open here. Apologize if you hear me sniffling. I got a sinus infection that I'm kind of getting over right now. It's the season. All right. So I've got that all opened up. Got the hot glue, for the most part, peeled back. When I put the new hot glue in there, it'll kind of bind everything together. So now I'm going to switch over to the solder iron, and we're going to desolder this guy. Heat that little guy up and pop it loose. And that's it. So I got the center conductor for my coax right here. Heat that up a little bit. I'm going to tin my soldering iron again. Put a little blobby blob on there. There we go. All right, so I got that all set up. So now I'm going to start measuring the new 6-meter element. So on this side, so the broke side, put my new element over here, get it out of the way. On my broken side, so 6-meter comes out to here, to the broke end. And I've got my little broke end here. So I think what I'm going to do actually is very carefully cut my binding loop. And all this is marine shrink tubing, so it's got the glue in it, and that glue inside does a really good job of kind of filling and sticking to everything in there. It helps it bind on itself a little bit better for these bites. There we go. All right, so I'm actually going to pull the heat shrink off of this. There we go. All right. Female end of the bullet connector just has another little female end here. So I'm going to pull this over here, desolder it. Perfect. So what this allows me to do is I have the broke end right here. I'm going to keep a hold of that. I have my new one right here. I'll get them exactly butted up against each other. Actually, I can 18 gauge. Yeah. All right. Tin my soldering iron real quick. Okay. There we go. That one's all bound together and set up to go inside the connector. But before I put that in the connector, I'm going to hold these side by side and match those lengths. Because like I said, dipole, you want it to be exact, or as close to exact as you can possibly get. So I'm just going to run down this guy here. All right. take my little cut bit here, leave the space. Now, just to clarify, the reason why this is stripped back is because out at the park, I was going to strip it and think about putting this back together just so I can finish that activation, but I remembered I had another dipole out there. So only one side is stripped. That is right there where it's supposed to be. Let's come up here, and boom, right there. Now the trick is I can see on here where the edge of the solder was. Where it was on there, I can see just that little lump right there. So I know that there was just a hair exposed. So what I'm actually going to do on this one is I'm only going to strip it back to that point. Because you can, I don't know if you can see on this camera, but you can see right there. You can see a little silhouette of where that wire was laying. Right in here. So I'm only going to cut back to that, and that will be my point of reference. And there we go. So let me get some solder on the end of that to hold it all together. Very nice. Okay, so let's hold these two up next to each other. There we go. So when I put this on, this is going to overlap just a hair like that over on this side. Okay, so I have my new flexed element. This is the repaired long one. Actually, I kind of want to just to double check. You always measure twice, right? Just want to double check. I'm going to nip a little off the tip here, as Mel Brooks would say. Okay, I'm comfortable with that. So now I'm going to weave this through, do the identical thing that I did on the other side. Idea of this is strain relief. This little guy is just going to, right there. Don't want the heat to be on there too long to melt the dielectric. Alright, you can already see that heat is working a little bit on the hot glue right there, softening it up some. But there we go. So now what I do is carefully feed this little guy back into here. And feed this little guy back into here. Feed that little guy back out. Tighten everything up. And now we switch over to hot glue. I'm just gonna make sure that I get that heat transfer into the old hot glue too. Make sure it all binds on itself and seals. Now we let this cool. As soon as this side cools completely, we're going to wrap that link through the connector. It's right here. Wrap that link through here. Solder the little female plug on it, and then we're going to go test it on the VNA. We'll get it set up. Make sure you put your heat shrink on first. Get that little guy pushed through. So I have noticed that the bite, the size and length of the bite matters a little bit. Not a whole lot, but it does. And this little guy is going to connect right back in there. Alright, so I have my female end of the bullet connector loaded in here. Soldering iron. I'm just trying to get all this kind of hot and bonded in there. I just want to add a dab more. Just a dab more. Just to replace what I took out. I'm just going to keep some heat on that. Get it all liquefied again. Get that in there nice and flush. And there we go. And now we check for fit. So you notice it's a little bit tight. So I'm going to give it a little slack on this end. And that works. So let's get some heat shrink on this this guy on this end here. So I've got the dipole set up here on the mast. I got the links pulled on the 6 meter section. And now we're going to go set up the VNA to see where we're resing it. Alright, so what we've got here is a dip at 51.440 megahertz. That's where my lowest dip is, and that's 1.006 to 1, right? That's kind of high in my opinion. I can't remember what I originally cut this for. Down in the CW section of 6 meter, it's still only 1.5, so it's realistically fine. But what I want to check is where the other bands sit. All right, so now what I've done is I've closed up the links on the 6 meter band, and I've opened up the links on the 10 meter band. We're going to take a look at it on the VNA and see where it sits. All right, so here we go. I've got 10 meters. The low point here is at 28,100. And if you get up into the technician phone range, you're still 1.2 to 1 SWR. Get up into general, 1.29 to 1, 1.3. So all the way up to 29 megahertz. So I did the sweep here from 28 to 29 megahertz, and the whole thing, the highest that I get in between there in the 10 meter band is 1.63. So that's fine. Even the FT710 can pull that in. Cool. All right. So now I'm going to jump up to 12 meters and check it to make sure that it's good. On 12 meter, I got the center point at, it starts at 24,600, which is well below the bottom of the 12 meter band. But even if I go, so let's go 12 meter is 24,890. So 24,880, 890 here. It's at 1.2 to 1. If I jump up to 24,990, we're still basically 1.3 to 1. I'm fine with that. I am curious what's going to happen as I get lower and lower and lower in the bands, though. So that's the thing with the link dipole. It is resonant antenna, so you're wanting resonant lengths, and it gets complicated the more and more links you put into it. So I'm still just fine, well below 1.5 on both of these. So let's take a look at 15 meters and see what 15 meters does. So here's the really curious thing. On 15, my resonant jumps. So I boogered this up somewhere. It's still fine in my opinion, but the top end is 21,670, which is like out the top of the 15 meter band. And when you actually get like well down into 15 meter, I'm getting closer to 2, so I'm still like 1 point down to CW digital. I'm still below 1.2 or 2. I'm sorry, I'm still below 2 to 1. Like the very, very bottom end of the 15 meter band is 1.8. Still curious, very, very curious. In my opinion, still okay, well enough that my tuner can bring it in. I'm not the only radio that I'm even relatively worried about on this is my True SDX, and my True SDX isn't even on high band, so I'm fine with this on my 710. My 710 brings it in just fine. All right, so let's jump in, check 17. All right, so 17 actually looks really good. Look at the bottom of 17 here at 1868. 1868, I'm at 1.1 to 1, and jump up to the top of 17 up to 168, and I'm 1.16 to 1. So yeah, I'm absolutely fine with that. Boogered 12 and 15. 17's fine. 20 is my workhorse. I'm really curious. I want to check 20 to see where my resonance is on that. So we'll check that. All right, so here's the curiosity. On 20 meters, my bottom end is right at 14 megahertz. So I can come up and hit the top end. I'm still at 1.59 to 1. I'm super curious. I want to go through it, and I'm going to recalibrate my my nano VNA, because now I'm stretched from, I started my calibration on 50 megahertz. Now I'm working on 14. Maybe I'm curious. So right now the low end is right at the bottom end of the 20 meter band at 14.06. So that's where the bottom end of the arc starts. I'm going to double check that and see what happens after I recalibrate. So I recalibrated, and it really only moved, it moved 20K. That was it. So that's really curious. I don't know what I did when I first cut this. I mean, it was a year ago, so I was pretty wet behind the ears back then. But even up at 350, 14,350, I'm still at 1.5 to 1. I haven't had an issue with it yet. I'm going to drop down to 30. I'm really curious once I start to get the lower bands. I'm going to drop down to 30 and check that too. Oh, it's so frustrating. I wish it was more predictable. Okay, so my center is at 9.94, well below the bottom end of 30. And then I get up into 30 here. I get to the top of 30. I mean, I'm still... I don't know if I just accepted what happened as accepted what I was getting as, oh, I guess that's good enough. I can't remember. It's been a while. But up here at 10.48, I'm at 1.5. I'm less than 1.5. But it is slightly short. I'm sorry. The antenna is slightly long. It's resonant slightly lower. So 10.100 is the bottom end of 30 meter right there. So that's my dip should be in between here, but it's way down here. Like I said, it's not awful. It's still below 1.5, but I expected better from my younger self. I don't know if it's the wire. I don't know if it's stretched while wound. I don't know if the wire stretched weirdly in a hot car over the summer. Like, I don't know. I'm super curious. Or just me beating the snot out of it over the year. So, all right. Well, let's try 40 and see what happens there. So 7 is almost exactly where I actually wanted most of my bands. Maybe a little bit long. It looks like all of these stretched. So if you look at the band plane here on 40 meters, where I wanted was right here centered between the bottom end of the general and the beginning of data and CW. So I wanted the center to be right there so I can get up into general and then also get down into to digital and CW is about where I wanted it. So roughly here, I'd say 7.15 is generally where I want it, 7.15. So 7.15 is actually right here, and I'm at 1.45 to 1. My lowest SWR is 1.03, but it's way down in CW section, 7.05. So it's well down in the bottom end of the CW section. So this is what I learned today. 1, my repair worked. 2, while it worked and all of the bands from 6 to 40 are good, some of them are high and some of them are low. Some of the sections are a little bit short. Some of the sections are a little bit long. Apparently, I need to recut my dipole. Everything is basically below 1.5 to 1. I'm fine with that for now. I'm going to continue rocking this thing on POTA. But I do apparently need to revisit this linked dipole in the future. So that was my repair. I'm happy to be able to get my main workhorse back out into the field and put my dainty little ultralight linked dipole back in the glove box for a rainy day. And I will see you guys out at the parks.